So, in the first part I compared the ability of Unreal Engine, Lumen and Ray Tracing to give a similar quality as a Corona render. Link to the first part in the description. By the way, in the voting, the Lumen render was the most voted for. The comparison wouldn't be complete without testing the most accurate rendering mode available in Unreal Engine. Today I will compare the Path Tracer and Corona render. The Path Tracer is a progressive hardware accelerated rendering mode that provides the ability to generate high-quality photorealistic renders with physically accurate results. Path Tracer method has some limitations. Due to limitation of the Path Tracer, I had to reconfigure the scene. In Unreal Engine 5.1, exponential high fog is supported in Path Tracing that has volumetric fog enabled. I tried setting it up, but I don't like how the render looks with exponential high fog, no matter how I set it up. So I made my own simple fog to be similar to what I have in other tests. I created the material, blend mode translucent, shading model unlit, because I don't need the color of the fog to be unaffected by the sun and the sky. Activate two-sided. Then I created a parameter for the color of the fog and its intensity. This chain is responsible for the gradient transparency of the fog from the ground to the sky. This adjusts the tiling of the noise texture. Then I create material instance. I applied it to the planes and positioned them in the scene. I like this result. It looks much better and processed quickly. To use the sky atmosphere, you need to change the transform mode, setting to planet top at component transform. The water material from the content engine I used with Lumen in the Path Tracer mode looks bad. I created a customized water material, blend mode translucent, lighting mode surface forward shading. I added absorption medium and created parameters for its color and influence strengths. This will allow to set a more physically correct shade of water. Next I set the parameters for base color, roughness, metallic, opacity and refraction. To create water waves I used this chain. I took the normal map for water from the content of the engine plugins. To access this content you need to activate its visibility. Go to Content Browser Settings and click on Show Engine Content and Show Plugin Content. Now it is available for use. These are material instance settings. Go to the scene settings. Activate support hardware ray tracing and path tracing. Pause process volume, path tracing. All I left the default values. Movie render queue, disable deferred rendering, add path tracer and anti-aliasing. Anti-aliasing. I did some tests and came to the conclusion that these are optimal values for the scene. Increasing the number of samples above this value did not lead to a noticeable improvement in the rendering quality of the scene. The best image turned out without choosing an anti-aliasing method. Path tracer settings I left by default. Output 4K resolution. I want to draw your attention to the fact that caustics in the path tracing are calculated in two modes. Approximate caustics, this mode is enabled by default, and in reflective caustics mode. Next I will compare both of these modes in detail. In order for the conditions to be equal, I activated the caustics in the Corona and reconfigured the water material in the pool. Due to the fact that the caustics in Corona take too long to process, I had to make some adjustments. In the Performance tab I disabled caustic from environment. I added all the glazing of the house to the exclusion list. Turn off the generation of caustics for all light sources except those in the pool. These are the water material settings. The water in the pool is made from a primitive box. Scene settings, 4K resolution, denoising mode, Intel CPU AI, path limit 40, post denoise amount 1, bloom at the end of the calculation for post-processing. Now let's render and compare the results. 4K resolution, render from 3 cameras. Corona render 9, caustic on, total render time 108 minutes 35 seconds. The displayed elapsed time in movie render queue with past tracer does not take into account the pre-rendering time, so I restored the actual elapsed time for each render from the screen recording. Unreal Engine 5.1 Past tracing method. Default Approximate Caustics. Total render time 12 minutes 31 seconds. It's almost 9 times faster than Corona. Now let's compare the resulting renders. This time the result is almost the same. Render in Unreal Engine is slightly more contrasty and has more warm color tones. Megascans in the background in Corona looks worse than in Unreal Engine. I guess that they need some additional settings. Now the medium shot in Unreal Engine and Past Tracer looks better than in Lumen, but worse than in Corona. Look at these assets. In Corona the detail is better than in Unreal Engine. Here you can see that the texture in Corona is sharper. Corona shows caustic artifacts and some noise. In Unreal Engine the image is clean, and I like the way the light from the window hits the wall. Reflections in Corona are sharper and more detailed, but in Unreal Engine the reflections are blurry. Just like the furniture outside the window in Corona, it looks more detailed. There are strong artifacts in Corona on the wall. It looks much better in Unreal Engine. Again in Corona, strong artifacts on the window slope. Here you can see how detailed reflections and refractions are in Corona and blurry in Unreal Engine. The foreground looks pretty much the same, only Megascans looks better in Unreal Engine. Water in both options looks good, but in Corona there are more details and there are artifacts. Camera 2. Corona light artifacts. The water in the pool looks better in Corona, but the noise from the Caustics is visible. Otherwise, both renders are the same. Look here, there is almost no difference. I like the light from the sky a little more in Unreal Engine, it looks more varied. The pool water looks great in both renders. In the end, renderings in Corona, detailed reflections and refractions looks great, but they contain many artifacts. Renders in Unreal Engine with Past Tracer lack in detail, but at the same time provide impressive quality considering the time spent. There are almost no artifacts in them. By default, Unreal Engine uses Approximate Caustics mode. This is the fast mode of calculation. To enable the Refractive Caustics mode in Unreal Engine, use the console command R Past Tracing Approximate Caustic 0. Let's compare these modes in practice. In order to better see the difference, I placed glass object in the scene. Approximate Caustics on the left, Refractive Caustics on the right. Here you can see the difference that Refractive Caustics look more natural, just like in this place. An interesting fact. In Refractive Caustics, the light on the wall disappeared in this place. The water in the pool looks a little richer. Now let's take a closer look at the water. Refractive Caustics look more interesting and varied. I will compare with a similar render in Corona. This example shows that the result of Refractive Caustics is closer to Corona. In Corona the Caustics are detailed and accurate, but with artifacts. In Unreal Engine it's simpler but without artifacts. And once again the pool in Corona and Refractive Caustics. Corona and Approximate Caustics. So let's summarize. Render results from 3 cameras. Unreal Engine and Lumen showed a very fast result. It completed the task 27 times faster than Corona. Unreal Engine, Lumen and Ray Tracing reflections took almost as long as Past Tracer. At the same time they showed a worse quality result than Past Tracer. These results call into question the use of Ray Tracing in a similar task. Unreal Engine and Past Tracer showed an excellent result in the ratio of time and quality of rendering. It completed the task 9 times faster than Corona render. At the same time it showed the ability to quickly process Caustics, providing fewer artifacts. Let's compare the results for one render in a complicated scenario. Unreal Engine Post-Tracer and Refractive Caustics give more physically correct results but take 55% more time to calculate than Approximate Caustics. This graph also shows that the time spent in Corona is 13 times higher than Unreal Engine and Refractive Caustics. For me personally, Unreal Engine proved once again that it's a powerful and flexible tool. If you add the ability to create interactive experience and virtual reality, then I consider it the best solution for architectural rendering and presentation of projects today. Thanks for watching, write your opinion in the comments. Links to all renders and project source file in the description. See you!